Hi, everybody. How you guys doing? Awesome. All right, the plan today. Absolutely, man. So over here, we're going to take a look at Dmvpn today. So this is my topology, the same topology that I had yesterday. I think I have some loopbacks. Let me just all put those loopbacks as well on the diagram. So I have 10.1 as a loopback over here. Let me put that on your diagram as well. These are going to be your private addresses behind these networks that are connected to the internet. These are the private networks that I actually want to route over the internet cloud. Good, everybody? So my objective again, tagging on from what we talked about last night, yesterday, is this. What I want to do is I want to connect Los Angeles, New York, Rome, Sydney, and Dubai to each other on a single tunnel network using the multi-point GRE tunnel, in which I would have one network, 192.168, let's say 1.0, with multiple points on it. What's the advantage of doing something like that? If I don't do a multi-point network and I have a whole bunch of different sites to connect up, I will end up doing what? Creating a whole bunch of different point-to-point tunnel interfaces. When you create a tunnel interface tunnel, whatever, the default tunnel protocol is what? The tunnel protocol by default is GRE, but the flavor of GRE that's a default is point-to-point. Basically, it will have one source, one destination. I need to change this. I need to change it into what? Multi-protocol or multi-point GRE, MGRE. Now, we also took a look at yesterday in terms of MGRE by itself. If you do it, it is not a scalable solution because in this case, I need to do a mapping for what? NHRP based on what? The private. For each one of those private addresses, I need to put the corresponding public address. If I have a multiple set of sites, then I would need to create a whole bunch of different mappings, and that's where we left off yesterday. Agreed? And then we also discussed the better way of doing it. What was a better way of doing the same type of setup? Using a dynamic mechanism in which I would set up one of the devices as what is known as my next hop server, NHS. I really don't need to do anything special on the next hop server itself. Just turn on NHRP under the tunnel interface, sets up the device as a next hop server. What I do need to do to set it up is I need to go to my clients, which are the other devices, and point to my NHS. My next hop server is 192.168.1.1. Because it's a private address, I also need to do a map telling the clients how do I reach that particular IP and the corresponding what? Public address. This is my public address assigned to me by my ISP. Everybody okay with that? Good so far? Now, once I do that, they will all be on the same network. They will all register to where? R1. As soon as New York comes up, Rome comes up, Sydney comes up, Dubai comes up, they will automatically go in and configure or set up a mapping on where? On the next hop server. I don't need to create any mappings on Los Angeles. They will all be created automatically because I have configured an IP address for my next hop server, which happens to be LA. Done? Let's take a look at the commands, the configs over here. I won't deploy it yet, but at least see the commands so you guys understand how it's done. So today we're going to do day 3. This is Dmvpn. I'm going to set up my next hop server, which in our case is R1, Los Angeles. Good. How do I do it? Interface, tunnel, whatever, it doesn't matter. It's locally significant. IP address 192.168.1.1. Tunnel source, let's say E0/0. Tunnel mode, GRE. Multi-point. Okay. And what else? Turn on my NHRP protocol. That's all I actually need to do on where? On my next hop server. What do I do on the clients? Which is basically going to be R2 through R5. Just do it individually. This was New York. This is your NH client, next hop client. IP address, the individual IP address that I want to assign it. So I'm on the same network as Los Angeles, different IP. Tunnel source, again, E0/0, whatever my public address happens to be. Change my mode. GRE, multi-point. All right. Turn on NHRP over here. Does it need to match? As I said earlier on, no, it doesn't. It can be any number. It is just to enable NHRP on that particular interface. Now, once I do that, now I need to now define who my next hop server is. I define the next hop server using the private address, not the public address. So it says IP NHRP NHS is 192.168.1.1. This is a significant command. Why is it significant? This is the command that tells my router, which is router 2, hey, listen, you need to go register yourself. Register your mapping. This is the command that initiates that. What mapping am I talking about? Your tunnel IP to your public IP. So he needs to map 192.168.1.2 to his public IP, which in our case is 20.2. Good so far? But now the problem over here is I don't know how to reach this because this is a private address. So what do I need to do over here? I need to tell it how. IP NHRP map to get to 192.168.1.1. The public IP is 10.1. So I need to give it one mapping, but the only mapping that I need to give it is the mapping for the next hop server. Everybody good with that? Cool? All right, so what do I need to do on the other client, the Roam device? Help me out with that. What do I change over here? What would change over here in this type of setup? The tunnel IP has to be different because I cannot have two devices with the same IP. How about the rest? Do I need to change the mapping? No, because I'm mapping towards what? I'm mapping towards the next hop server, and that's the same. You get my point? The fourth one was Sydney. Put 4, and this is the mapping. You guys see that? Everyone has pretty much the same config, pointing towards what? Pointing towards the next hop server, the NHS. And based on this config, what's going to happen is on R1, Los Angeles, what am I going to get based on the registrations? A next hop server or next hop mapping database will be created. The NHRP mapping database will be created on R1, which will look like this. To reach 192.168.1.2. The public address is 192.1.20.2. Who would have registered this? R2 would have registered his public and his private IP. And this type of mapping is known as a dynamic mapping. Because I didn't configure a command for it, it was done by the client. Similarly, I'll have what? 1.3. One dot 4, the public address, dynamic. What does dynamic mean? It was not done by putting a command in. The client came in and registered. How about the mappings on R2? What's a mapping on R2 going to look like at this point? I'm going to have one mapping over there, the one that I configured manually. Correct? How about R3? Same thing. Sorry. How about R4? Same thing. And all these mappings are going to be static mappings. Everybody okay with it so far? Now, if R2 wants to communicate to R3, he does not have a mapping. So if he goes in, somebody sits on R2 and says, let's see if I can reach R3. He types in ping 192.168.1.3. It will check the routing table. What's inside the routing table? It will discover that 192.168.1.0 is directly connected over the tunnel. Agreed? So that means it's on the same network as R2. So the next thing to do, because it's on the same network, is to do what? Check the destination. What's the destination over here? 192.168.1.3. Checks it where? In the NHRP table. Would it find it there right now? No. So what does it do? Because it does not find it there, it is going to send a request to whom? To R1 saying, who is? Why does it do it? The implications of putting the IP NHRP NHS command is twofold. It does two things for you. Number one, when you put the IP NHRP NHS command, it tells your router that it needs to do a registration, which was done over here. This is a registration that it sent. Initially, as soon as the interface comes up, go register. The other implication of this command, putting this command, is if you don't have a particular mapping, go ask the NHS. So the purpose of the NHRP NHS command is twofold. What are the two things it does? Initially, when the interface comes up, it needs to register itself. And later on, if it does not find a mapping that it's looking for, it should ask it. Very similar to DNS, dynamic DNS. When an IP address is assigned to a client, the client will register itself with the dynamic DNS server to tell it, hey, listen, this is the IP address that was assigned to me. This is my host name. Later on, when it needs to resolve an address to somebody else, it will go back to the same dynamic DNS server. Same concept over here. Okay? So it will send that request to the next hop server. What does it get back? Based on this mapping, because R3 would have registered as well, it puts it into the next hop resolution database. And this mapping is going to be dynamic. Yesterday, I told you the lifetime of this. What was the lifetime of this mapping by default if you don't change the parameters? 2 hours, 7,200 seconds. You can change that if you want to, but the default is 7,200 seconds. Now, from this point on, R2 will now send the packet directly from where? R2 to R3 and vice versa. Good, everybody? Now, I want you guys to pay attention over here because this is where a lot of people get confused. And I want you guys to make sure you understand this properly. What I just showed you, the explanation that I gave you guys. First packet is sent to R1. R2 sends it to R1 for what? Resolution. Once it gets the resolution, then it sends the packet to R3. And you can see that. If you do a trace route, you'll see that. Now, what I showed you over here was a unicast mapping. So if I want to communicate on this common network, my directly connected network that I have, the 192.168.1.0 network, this is the way communication is going to work. The way I explained it to you guys right now. So at this point, I should be able to go from 1 to 2 to 3 to 4 to 5 directly. The thing though is you need to understand, I'm not setting these routers up so the router can ping each other. What was my purpose of setting Dmvpn up? What was the main purpose of setting it up? It's not the communication of the routers. My main objective is to allow communication of what? 10.1 to 10.2 to 10.3, the LAN segments. Agreed? And in order to get the LAN segments communicating to each other, you need to have routing in place. Correct? So unless you have routing in place, you would not be able to communicate between my LAN segments. And that's my main objective. It's not to allow router 1 to talk to 3, 4, or 5, or any of those different combinations. My main objective is to allow the LANs to talk to each other. I haven't accomplished that yet. And why not? Because I don't have a routing protocol. Now, what do I need to run a routing protocol? Let's say I ran a routing protocol on R2. I said router EIGRP 100, network 192.168.1.0, the tunnel network. And I'll say my other network is my N network, the LAN segment. Agreed? As soon as I enable EIGRP on the tunnel interface, it now will start sending my EIGRP hello packets. What does an EIGRP hello packet look like? It goes out of the outgoing interface, which is 192.168.1.1, because I ran it on the tunnel network. And yesterday I also showed you the multicast address it uses, which is 224.0.0.10. Right? Where does it send that packet to? Right now, there's only one map over here. What is that one map over here? It says if the inside destination is 192.168.1.1, send it to 192.1.10.1. Remember, I told you this is the mapping between the inner destination to the outer destination. If the inner destination is 192.168.1.1, this is the outer destination IP, right? But take a look at this packet. What does it have over here? Does that have a mapping over there? Would it be able to send a routing update? So what should I put on the outside now? I know my source, tunnel source is going to be my public address, but what's my tunnel destination? I need to do a mapping that would allow me to put a corresponding address where? In my outer header. I need a mapping for that, so that every one of them sends their multicast updates for your routing protocols to whom? To your next hop server. As long as I can get it to the next hop server, he can then exchange the routes with the other guys. But at least let's get it up and running with a relationship with my next hop server, which is Los Angeles. So besides having my normal Unicast mapping on my clients towards whom? My next hop server, I also need to tell my clients that, hey, listen, if a packet comes in which has a destination as a multicast, also send it to whom? 10.1. And I need to do this where? On all my clients. This will allow me to do what? Send my multicast update to my next hop server. So when a packet comes in that looks like this, 192.168.1.x going towards 224.0.0.10, whether it's router 2, router 3, router 4, router 5, what have I told it? If you get a multicast destination, send that packet to whom? If the inner header is what? Multicast, send it to R1. So all my EIGRP updates will be sent to whom? To 10.1. Who is my next hop server? Good so far, guys? So you understand what this is doing over here? It is a must for your IGPs, because all your IGPs are running what? Multicast as a way of communication. The problem is, once I send this hello packet to R1, R1 receives it. It strips the outer header off. What does he see? Somebody sending me a hello packet, fine. 192.168.1.x is sending me a hello packet. So I need to send my hello packet back to him. The hello packet that R1 sends is going to look like this. 192.168.1.1. 224.0010 because it's a multicast hello. Who does R1 send it to? I am NHS. So I have received the hello packet. I also, when EIGRP communicates or OSPF communicates to its neighbor, it will send his hello packet back so that they can establish a neighbor relationship. It is not sent back to the sender. Hello packets in EIGRP will have a destination as a multicast address. So I send you a multicast hello, you're going to respond back with multicast hello. That's how EIGRP works. It's not a response. It's not like a reply. You get my point? It's not unicast, it's multicast. So when I send you a multicast hello, I expect a multicast hello back from you. All the registers clients, but how? Did I specify anything to that effect over here? You're right, you do need to send it to all the registered client routers, but at this point, there's no command to do it. It doesn't happen automatically. You need to do something to tell it to do that. And that's something on the next stop server, which is this guy over here. No, sorry, this guy over here, Los Angeles. Remember, I don't have any NHS commands or anything like that over here. I don't have any mappings over here. I do need to have one map, which basically says if you need to send a multicast address or multicast packet to anybody, please send it to any client that has registered dynamically. So it goes into the NHRP mapping table and looks at all the clients that have registered dynamically. One by one, it is going to send a packet to each one of those clients, the hello packet. So how many mappings have happened right now on my R1? Dynamically on R1, on Los Angeles. I would have a mapping from where? 2, dynamic, 3, dynamic, .4, dynamic, so on and so forth. Do you guys agree? Kind of unicast, yes. In the inside, it's still a multicast, right? But on the outside, because I've said map multicast dynamic, any dynamic entry that you have, it is going to create a separate unicast packet, sending it from my public address, which is 192.1.10.1, to whom? What's my first dynamic? 20.2. Then it's going to do the same packet again, one at a time. It is also a multicast packet, but he's going to send that now to whom? So it goes down the list and sends a unicast hello to each one. It's unicast on the outer header, but it's a multicast on the inner header. The routing protocol is going to check the inside packet. It's not going to check the outside packet. Do you understand what I did? That would allow me to establish a routing adjacency between the different routers. Good so far, guys? So the next stop server, when it sends an update down, it will send it to each and every client that has registered dynamically to it. okay, by creating a unicast packet towards that dynamic destination, but the actual internal packet is still going to be a multicast packet. Absolutely. If it goes down, your routing table goes out. Now you might say, why don't you set up a neighbor relationship between all the different routers? But again, then I would need to, number one, it's not a scalable solution. It's not an efficient solution, because then what's going to happen is I would have multiple neighbor relationships that I need to maintain. If I had 20 routers on this single tunnel, I would have to have 19 neighbors managed. All right. So it's not a feasible or a scalable solution. So better to do it based on what? In terms of routing, to do it based on hub and spoke. So this becomes your routing hub. So in terms of routing, this guy over here, this is your next hop server for right now, and it is also known as your routing hub. Now, in terms of routing, everyone will establish a neighbor relationship only with the hub, the routing hub. The router 2 is going to send a routing update to whom? R1. Router 3 is going to do the same thing. 4 is going to do the same thing. 5 is going to do the same thing. It's R1's responsibility of letting everybody know about all the other routes. You might say, well, this is a single point of failure. Absolutely correct. That's where later on I'm going to show you where you should at least have 2 what? Next hop servers and 2 routing hubs. Very true. And just like in BGP, when you have a route reflector, you don't want to keep one router as a route reflector. You always do it in a cluster of at least 2. Agreed? But for right now, let's understand it with 1. Then I'm going to expand it and scale it to 2 next hop servers. Understand how it works with 1 for right now. Clear so far? Now, if you do it based on unicast, then you don't need to do the multicast entry. But then you need to go to each and every router, do the neighbor command. Got it again? So it's not necessarily the best way to do it, because again, it is not a scalable way of doing it. If I had 20 routers, I would need to have 20 neighbor commands on R1 or 19 neighbor commands on R1. And at the same time, I would need to go to each and every of those clients and point the neighbor command towards the hub. You're not really buying anything. Absolutely, you're doing it like MGRE. Now, let's get this running. Let's see if it works, and then I'll go deeper into it. So on R1, what did I do? Interface tunnel 1. The IP address, tunnel source, mode, network ID, map multicast dynamic. While I'm at it, I'm going to run my routing protocol. I'm going to do EdgeRP for right now. Run it on my 192.168.1.0 network, which is my tunnel, and my internal network, which is 10. So this is going to be my configuration on my next hop server. Everybody okay with this, guys? You guys understand what I just did over here? Any questions about any of the commands over here? That is correct. That's all I got to do. You need to go and put the NHS command on the client. You don't need to do anything special on the actual NHS server. It is all a router can become an NHS server at any given time. It's on by default, capability. So copy it. We'll go to router 1 and paste this config. Good. If you take a look at your mapping over here, show IP NHRP, you'll notice I don't have any mapping. Why don't I have a mapping right now? The reason I don't have a mapping right now because the clients are not configured to register. Not the IDP, the client. I would get a mapping even if I just bought the tunnel up. Don't necessarily need the IGP for that. No, not neighbor relationships. Let me do this. Although I'm going to copy it, I'm not going to paste this. I want you guys to understand, first thing that I'm establishing over here is the communication on the tunnel interface. So notice I don't have any EIGRP over here. Okay, I just have the tunnel configuration at this point. I would still do my registration of what? My NHRP just based on this configuration. Why? As soon as my interface has IP NHRP NHS, that itself says go register your public and private IP. Okay, this is for the multicast part of it, when the IGP will be established. So I don't need an IGP to register my mapping. Take a look at it. I'll go to router 2. Router 1, no mapping right now. Let's go to router 2. Notice all I did was do the tunnel interface configuration. I didn't do any routing on router 2 yet. I don't have any routing over here. Section router is blank, right? But on R1 now, I will have a mapping created. Who has registered? 1.2 has registered with a public address of 192.168, sorry, 192.1.20.2, interface IP of E00. Understood that? So that's a unicast registration that has taken place. If I run my EIGRP over here, it is going to establish an EIGRP neighbor relationship because of the map multicast. EIGRP is going to try to initiate a 224.0.0.10 destination, and because it's a multicast, it's going to send it to R1. R1 is going to respond back. Why? Because R1, notice this is what? Dynamic over here. And in my NHRP map multicast, I've said send a multicast packet to all the dynamically registered clients. So that will establish the EIGRP neighbor relationship. Let me just run routing over here now. As soon as I run routing, it has established my neighbor relationship. So if I do show IP EIGRP neighbor, I have a neighbor on 192.168.1.0. I go over here and check my routing table now. I've learned the N2 network via what? 192.168.1.2. Everybody clear on this? Absolutely clear, no doubts, because I want you guys to make sure this is there. This is your foundation for Dmvpn. All right, good. Now, what do I need to do on Roam? I had already done the config. I just need to add the routing bit of it. As soon as I copy this onto R3, again, I'll go to router 1, show you the mapping. Just one map, just one route. If I go to router 3 and paste my tunnel and routing configuration, the tunnel is up and my EIGRP neighbor is up. So if I go down over here, first of all, the mapping. I got a new mapping over here registered, right? And I should also have a new route. Working like a champ. Do the same thing for what? Sydney. This R4. There you go. And if I look at my NHRP table, now I have a third mapping. Number 4 is there as well. And to complete it, absolutely, very simple configuration on the NHS. neighbor up, check my mappings. Good so far, guys? Now, at this point, I have my base network set up. I still have issues. I'm not completely done here over here yet. What's the issue? The issue is my routing protocol. What routing protocol am I running over here? EIGRP, right? Well, if you look at your topology, R1 is receiving a whole bunch of different routes from R2, from R3, from R4, and from R5. From how many interfaces? What interface is it receiving all the routes on R1 from? And that's the issue, but that's not my question. The question was, what interface is it receiving on? It's the tunnel interface, right? And as some of you guys said, the issue is split horizon. Why? In EIGRP, when I receive a route on an interface, I'm not going to send the route back on the same interface. So what I showed you over here is the routing table of what? R1, which has all the routes. No problems, all received through tunnel 1. But if I receive a route over tunnel 1, as EIGRP has split horizon turned on by default, it's not going to send the route to the other neighbor. So if I go to router 2, I check my EIGRP route, I will see the route from the next hop server from Los Angeles, but I don't see the routes from the other sites. Same thing over here on R3. Just a route from where? From the hub. So I'm going to use EIGRP as an example right now as the Dmvpn routing protocol. EIGRP has split horizon turned on by default. The spoke routes will not be propagated to each other as they are all received from the same tunnel interface. So no, I'm not interfaces yet. It is just the way EIGRP works. So you need to do what? As a mandatory step, you need to disable split horizon. I'll get into phase 1, phase 2, and phase 3 later on. This is a mandatory step before you even get to phases. Phases is after the routes are propagated. Right now, I don't even have the route, so I don't have full reachability yet. Got us, Nat? So first thing that I need to do to establish full reachability, you need to disable split horizon on the routing hub, which in our case is what? Los Angeles. How do I do it? Interface tunnel 1, no IP, split horizon, EIGRP, what did I have? 111. That's how you disable it for EIGRP. As soon as I do that, remember I only have one routes on all the different spokes right now. As soon as I do this, where? On the hub? Not in this case. Not in this case because I'm not establishing any neighbor relationship between what? From the spoke to spoke. So all the neighbor relationships are established to the hub, so it's okay. So because I changed split horizon, it resets the neighbor relationship, resyncs it, and because of the resync, what should you guys have right now over here? Not neighbors, I will only have one neighbor, which is going to be my hub. But I have the routes from the other neighbors. Got it, Tim? I don't establish neighbor relationships between 2, 3, 4, and 5, which is a good thing because otherwise the routers would need to maintain multiple neighbor relationships. All of them are right now only maintaining one neighbor relationship towards the hub, but the hub is the one that's propagating all the routes to them. Good, everybody? Absolutely, the hub. The routing hub, NHS, whatever you want to call it. Right? So this is your foundational Dmvpn that's running at this time. Now, there's different ways of using Dmvpn. Same concept, you just disable split horizon under the name mode, which will be under the address family IPv4. Normal route filtering the way you would do normal route filtering. Because EIGRP allows you the ability to do filtering on an interface level. You do have the ability to filter it out. Coming in. You wouldn't do it on the hub though, because hub is the same interface going out. It's a single interface. All right, good so far, guys, at this point? Summarization is possible. We'll take a look at where summarization becomes, it's actually a good thing to do. I'll show you that in a bit. We'll get into summarization. You can do summarization if you want, and it's a good thing to do in some cases. Now, at this time, the next thing I want to take a look at right now, my control plane. Control plane means the propagation and learning of the routes. In this setup is done to a hub and spoke manner. You guys understand that? Right now, my control plane, which is my routing information, right? What's the topology of your control plane right now? All the routes are propagated to what? LA, and LA is the one that sends the routes to everybody else. Agreed? This is the control plane. In terms of data forwarding, you still have a choice of how the data will be forwarded. If you want data to be forwarded in a hub and spoke manner, you have a choice of that. You can send the data to the hub, and the hub in turn will say where this data is allowed to go to by using an ACL. Where? On the hub. So if you want control in terms of what spoke communicates to what spoke, you have the ability to set your data plane also in what manner. In a hub and spoke manner. What's the advantage of doing the data plane in hub and spoke? What's the advantage of doing data plane in hub and spoke, where if New York wants to talk to Dubai, it needs to go to LA first and then go to Dubai? Why would I want to do something like that when I could go directly from New York to Dubai, because both of them are connected to the internet? If the hub, the headquarter, wants to control what traffic is allowed to go from New York to Dubai, this is a better way of doing it. You understand that? Yes, in terms of, if you take a look at it from the perspective of performance or data forwarding, it is suboptimal forwarding. Just to draw a map the proper way, don't go by the way they are right now over here. If you look at the map, this is New York, this is LA, This is Dubai. This is Rome. They're all connected to what? The internet. If right now Dubai wants to talk to Rome, if I wanted to do hub and spoke data forwarding, the packet will go where? To LA first from Dubai, and then LA will send it to whom? To Rome. Suboptimal forwarding. You might say, well, that's a bad thing to do. Yes, you're right. In terms of forwarding, it's a bad thing to do. But in terms of control, maybe you do want to control what traffic goes from where? Dubai to Rome. In that case, you might want to do what? Hub and spoke. The reason I'm saying this is a lot of people automatically, when they take a look at hub and spoke, jump to the conclusion it's a bad thing. You understand that? So it's not necessarily a bad thing. It might be fulfilling a requirement of the company. Understood? So it depends on how you want to set it up. Yes, my control plane, which is my routing updates, it is all traffic is going through LA, which is okay. Because routing updates, once the actual router exchange is just a hello packet. 100 byte hello packet. Less than 100 bytes. Good so far? Now, when I control my data, if I want to do hub and spoke data, it is known as phase 1. So phase 1 is when I want to set my data path as what? Hub and spoke. If I want direct communication where I want Sydney and Dubai or Rome and Dubai to talk to each other directly, yes, my routing updates are going through LA, but my data communication should go directly. I'll show you how you can also set that up, which is spoke to spoke. This can either be done by using phase 2 or phase 3. I will, as we go through it, I will show you the difference between phase 2 and phase 3. But phase 2 and phase 3, both of them are spoke to spoke data communication. So if somebody asks you what is the difference between phase 1 versus 2 and 3, for right now, phase 1 is hub and spoke data, and phase 2, phase 3 are spoke to spoke. To make the difference between 2 and 3, I will show you that as well. But for right now, understand the difference between 1 versus 2, 3. Everybody okay with that? Phase 2 and phase 3 support spoke to spoke communication. Phase 2 and phase 3 are data spoke to spoke communication. So the characteristic that makes it phase 2 is spoke to spoke communication. You get my point? Good so far, guys? So now let's take a look at phase 1. So at this point, my EIGRP was up. My next objective over here is to show you the 3 different phases. And right now, I'm going to focus on just EIGRP. We'll do the same thing with Ospf, but let's do EIGRP first. By default, EIGRP works as hub and spoke in terms of data. So by default, what I just did with the EIGRP, just disabling split horizon, has set the EIGRP in phase 1 or hub and spoke. That's the default behavior of EIGRP. And I'll explain the reason for that as well, but understand that by default, phase 1, what I have right now is what? It's, sorry, what I have with the EIGRP right now is phase 1, which is hub and spoke data. The reason behind it, if I take a look at my routing table, let me go to R2. Take a look at your routing table. Everything points via what? R1. You see that? If I go to 5, everything points towards what? R1. Same thing with 4. And same thing with 3. And the reason for that, when EIGRP sent an update from New York to LA, he gets a route 10.2.2.0/24 via 192.168.1.2. Everybody clear on that? When it got a route for 10.3.3.0, R1 got it from 192.168.1.3. Agreed? Now, normal routing paradigm, the way routers work, if A sends a route to B, what is B's next hop? If A sends a route to B, what's B's next hop to reach that route? Is A, right? When B sends it to C, what is C's next hop? B, isn't it? That's normal routing, isn't it? Isn't that what's happening over here? Take a look. Router 2 send a route to 1, 10.2.2.0 via 192.168.1.2. 1 sends it to whom? 3. What is the next hop over here for Rome? So he should get 10.2.2.0 from whom? From R2 or R1? R1. Isn't that what you guys are seeing over here? Just check, making sure. Yeah? Good so far? Everybody okay with that? Do you understand why R3, R4 is preserved? Not preserved. It is not preserved. Preservation would be if when I got the route from R2 with the next hop of 192.168.1.2, I would send it to 3 as .2. I didn't do it. I changed it to myself, which is normal. That's what I showed you. When A sends it to B, B's next hop is A. But when B sends it to C, C's next hop is B. That's the default behavior of a routing protocol, specifically EIGRP. Now, let's say I sit over here and I do a ping to 1 to 10.2.2.2. What does it do? Checks the routing table. And what does the routing table tell it? So the packet is created. Let's say 3 is sending the packet to 2, creates a packet, and 3 is sending a packet to N2. What did I tell you? The first thing that happens is a routing check. Route check tells it to get to 10.2. Over here, go through 192.168.1.1. Now 192.168.1.1, it does a recursive lookup at this point. Recursive lookup means, how do I reach 192.168.1.1? It's directly connected to you. See? So the first thing it does, it goes in, pay attention guys, this is important. So when it sees 10.2 over here, it figures out that 10.2 is reachable via 192.168.1.1. Now, where is 192.168.1.1? It says, oh, it's directly connected over the tunnel network. Tunnel, when it goes and checks the tunnel, it says it's MGRE. MGRE automatically points to what? NHRP table, mapping table. What am I resolving right now? I'm resolving the next hop. What's the next hop? 192.168.1.1. So if I check my NHRP table over here, I am going to see what over here for 192.168.1.1. Send it to whom? R1. So I'm going to create this outer header like this. I'm on R3, send it to 10.1. So where does this packet get forwarded to? To R1. The reason is my next hop over here is pointing to what? To R1. Because it's pointing to R1, I am going to resolve R1 over here. So I'm going to send every packet to R1. Take a look. I'll show you two things over here. Number one, I'm going to show you if I ping. I won't even do a ping. Let's do a trace route, because trace route will show you the actual packet. Let's say I trace route to 192.168.1.5. What's going to happen? I'm actually going to address on the same network. I'm not going to a different network. I'm going to the same network. When I do a trace route to 192.168.1.1, what does it check? Again, it checks the routing table. What does it see in the routing table? No, it doesn't see for 192.168.1.0. It doesn't see in the routing table go via R1. Check again. If I'm doing a trace route to a destination of 192.168.1.0, what does it check in the routing table? Because the first check is the routing table. Is it directly connected? Is it somewhere else? 192.168.1.0 is directly connected red network. So in my routing table, it hits this. Because my destination is what? 192.168.1.0. Guys, pay attention over here. This will actually show you how Dmvpn works internally. So when I say tunnel trace route to 192.168.1.5, the first hit in the routing table is this guy. It says tunnel 1. So tunnel 1, because it's directly connected on the same network, it says I need to do what? Resolve it based on my NHRP, and I am resolving 192.168.1.5 because it's on my network. The destination is on my network. But does it find it there? I only have one mapping. What's it going to do? I don't have a mapping for it. You guys remember what I told you? It's going to send a resolution request. To whom? To NHS, saying who is 192.168.1.5, because I'm communicating to a device on my network and my routing table says it's directly connected to you. Okay, so I'm resolving for this address and see what happens. That is correct. That is correct. Notice 2 hops, 1 and then 5, right? Take a look. If I do it again, now it's going direct. It's not 2 hops anymore. It's what? 1 hop. The first time it did 2 hops because of what? The resolution. If I go back and check my table now, you will notice I have a new mapping over here, which is 192.168.1.1, which was created dynamically. And this is the public address. So now I'm going directly from 3 to 5. Understood? And why did this happen? NHRP was still there, but it was static mappings at that time. With the NHS, I'm doing dynamic mappings, making it Dmvpn. The NHS is the one that made it dynamic. Up until that time, it was static. What if I do a trace route? Let me do a show IP route first. What if I do a trace route to 10.2.2.2? Tell me what entry in the routing table does it hit? Does it go to the directly connected or does it hit on the 10.2? Do you see that? So now when it sees that, it says, oh, via 192.168.1.1. But now when the resolution is taking place, it's not happening for any other address. It's happening for this address. And whether you do it once or you do it 10 times, if I'm resolving to 192.168.1.1, I'm always going to get one answer, and which is already there in my table, by the way. It's the static entry 10.1. So all my packets, not just the first one, but all of them will go through the hub. Good so far? So I can keep on doing it all night long, because every time I type in trace route to 10.2, this is my destination. It checks my routing table. What does it see in the routing table? It sees this guy. And the next stop for this guy is this 192.168.1.1. So every time it's going to resolve to 192.168.1.1. And every time the packet will go through the hub. Understood? So what is my data path over here? Every time it is always going to be through the hub. And what's the reason for that? The reason for that is that my EIGRP is changing the next hop to itself. Okay. Now, do we need to modify the next hop then? Think about it. What did I tell you? Maybe you want to do hub and spoke. Maybe you want to do phase one. Why? You want to control traffic going through the hub. So the thing that I want to make sure you guys understand is hub and spoke is not necessarily bad. When we do that, when we deem it as bad, we're only looking at it from the perspective of the glasses of performance. We're not looking at it from the glasses of control. Maybe you do want to control it, and hub and spoke is a way to do it then. Do you understand what I'm trying to get to? I want you guys to understand you always look at it from the perspective of the design, the requirement. But we're so engulfed in, oh, I want to get it there the fastest. So to us, hub and spoke is always bad. All right. So whenever you go into an environment, ask the requirements. And then based on that, you give it the proper design. Personally, I don't believe in best practices. The reason I don't believe in best practices is because best practices are too rigid of a way of looking at technology. You need to analyze the requirement, and then for that particular requirement, what are the best practices? Do you understand where I'm coming from? But what I see a lot in the industry is that people have their cookie cutter systems. Oh, this is good, this is bad, which is wrong. All right, so you guys are okay with phase one. This is phase one. I didn't need to do anything special. By default, EIGRP works as hub and spoke in terms of data. This is because the routing hub, which is the NHS, changes the next hop attribute of the routes that it propagates towards the other spokes to itself. This causes the spokes to resolve the next hop to the hub. All the data packets will be sent through the hub, which is not a bad thing. So I'll write a pro and a con. Pro, as all traffic, is propagating through the hub, it gives you more control on the data flow from one spoke to the other. Maybe that's what you want. If that's the case, that's basically what you've accomplished. Con, suboptimal forwarding. Now you need to take a look at what is more important to your company or your environment. Good so far, guys? Phase one, easy enough. You didn't need to do anything. Just enable EIGRP, disable split horizon on the tunnel. You're doing phase one. But now I want to go to the other company that wants to do spoke to spoke. All right, guys, no redundancy. We'll get to the redundancy part later on. We will definitely do redundancy as well, but let's focus on this one. What triggers EIGRP to change the next hop to itself, you mean? That's the default behavior. That's what I was talking about. Remember this A to B? When normal behavior for routing protocol, A sends a route to B. What's the next hop for B? It's A. So think about this being R2 and this being B hub, R1. When B sends it to C, what is C's next hop? Is B. That's default behavior or what? Of a routing protocol. Again, good with that? Now, the other way around, let's say I don't want to do that. Why? I know A and C can communicate to each other directly. I need to do something to tell it, hey, don't do it. Don't do the default behavior. So that is phase two. And this is, again, I'm doing it for EIGRP. If you want the data path to go directly from spoke to spoke, you need to tune your routing protocol in such a way that it does not change the next hop. Okay, if it doesn't change the next hop, what happens? What's the result of that? When he sent the routing update over here to him, it was D for EIGRP 10220 via 192.168.1.2. If I tell it don't change it, which is not the normal way of doing it, if I tell it don't change it, what happens is R1 will send the route to Rome and he will get the route exactly the same way. 10.2.2.0 via Because it's unchanged, it's going to be 1.2. Because I'm going to tell it, don't change it. Let it be like that. So similarly, I'm going to get 10.3, and 3 is myself, 10.4 via 192.168, 1.4. Now what happens is, if I do a trace route or a ping to 10.4.4.4, for example, in my routing table, what is it going to hit? It's going to hit this entry, which is telling it the next stop is what? 192.168, 1.4. Now it is going to send a resolution request over here to tell it, hey, who is 192.168, 1.4? So he's going to resolve 192.168, 1.4 to 40.4, right? So in the packet, the internal packet will look like this. I'm going from Rome. So 10.3, 10.4, and the outer header is going to look like this. From Rome 30.3 towards 40.4. You get my point? So now the packet is going to go through the internet directly from, not Rome, where was I going? To Sydney, Rome to Sydney. It doesn't have to go to LA to come down to Sydney. So what do I need to do this? How do I get the routing table to look like this? Because the default right now, I'll do a before and after again, so you guys can compare. I go to router 2. Pointing everything to 1, pointing everything to 1. Pointing everything to 1 and 5. Pointing everything to 1, right? Now what I'll do on R1 to change that behavior, under the tunnel interface, no IP next hop self for EIGRP 111. Don't change the IP to self. Let it be. Let it be the way it is. So when 2 sends the update to 1, 1 sends it to 3, 1 will not change it because I'm telling the hub, don't change the next hop now. No, don't change the next hop to self for EIGRP 111. Take a look at the change. If I go to router 2 now, to go to 3, to 3, to go to 4, to 4, to go to 5, to 5. Here it's going direct. Okay, same thing where on 3, 1, 2, and 4 and 5. On 4, it'll be 1, 2, 3, and 5. On 5, it should be 1, 2, 3, 4. That's what the no IP next hop self does. Do not change the next hop to yourself. Leave it as is. Leave it unchanged. So now, if I'm sitting on R5 and I want to go to, let's say, I'm on R5, which is Dubai. Dubai wants to go to Rome. So I'll say 10.3.3.3. Source 10.5.5.5. What does the packet look like? Source 10.5. Destination 10.3. It checks the routing table. What does the routing table check? Tell it for 10.3. That 10.3 is reachable via 192, 192.168, 1.3, right? So the next thing that I'll do is I'll try to find out who 192.168, 1.3 is in the resolution packet. In the resolution packet, what does it see? The destination comes back to be 30.3, and my source, I'm on 5, should be this guy. So the packet now will go directly from Dubai to Rome. The first time around, it's going to go to the hub. All right? Clear? So let's check it. You want to do a debug, you can do that as well. Which one do you want to do? Again. So now if I do a trace to 10.3.3.3, I already had a mapping for it. See, this one was done earlier on. Remember that one of the things that I had done? Let's do it to 10.2. I don't have a mapping for 10.2. This should trigger an NHRP. There you go. Why didn't it do it the first time around? Because I had already done one trace route, so I had the mapping already. Correct. Send resolution request via tunnel. For what? For the destination for 192.168.1.2. And that's the response. So notice over here, it was 2 hops, right? Now if I do another trace route, it's going to be direct. Why direct? Because I now have the mapping for it. Where is 2? There you go. From this point on, direct packets to 2. How about 3? 3 will also be direct. Why? How come? Because I had done the 3 already. How about if I do 4? What's going to happen with 4? I don't have a mapping for 4, right? I have it for 1, 2, 3, 5 is myself. What's going to happen with 4 if I try to trace to 4? Because the next stop for 4 is not in my NHRP table, so it needs to do the resolution. You'll see the NHRP debug until it gets client NBMA as 40.4. Good. Now you should have that as well. So now I can go to Dubai, from Dubai to any of those sites directly. I did NHRP, debug NHRP packet. This is the one. All right, so let's write that down for you guys over here. How do I configure this? It will automatically reset the neighbor relationships and update the next hop value on the spokes. But in terms of routing, the routing bit is still through the hub. So I still only have one what? Routing hub. So my EIGRP is still like this. My routing updates are still going to go through where? Here. But my data flow is direct. This is what? This is Dmvpn phase 2. You guys okay with this? Good. So if you take a look at this over here, we are done with this much so far. Good time to take a break. We'll come back. We'll take a look at phase 3. We'll take a look at redundancy, Dmvpn. I'm going to encrypt it using Ipsec, and I'll also show you how Ospf runs over Dmvpn. No, that's not true. This is phase 1. Hub and spoke is phase 1. I will do that. Break. Let me put the notes over here for the break, and then you guys can copy it. You also need to tell me where do you want to have it. Is this good? So the break is from 11:01. Let's take it till 11:16. 15 minutes. We come back and we take a look at the remaining of Dmvpn. Still a lot of good stuff still coming up. All right, break time. Hello, hello. You guys back? Still there. Any questions from the first session? You good with this? Yeah? So my objective over here now is to do the same thing with phase 3. If you guys remember, when I was breaking down hub and spoke to spoke, what did I mention? That hub and spoke is phase 1, and spoke to spoke can either be phase 2 or it can be phase 3. You guys remember that? As I said, in terms of phase 2, it's basically spoke to spoke communication. Okay. The way I accomplished the phase 2 spoke to spoke communication in phase 2 was tweaking the routing protocol. So actually, I should put that over here as a note. If you want the data path to go directly from spoke to spoke, you need to tune your routing protocol in such a way that does not change the next hop. This causes the data path to be direct between spoke to spoke. All right. It's the flow. It's neither the routing protocol, it's not the GRE type. It's the flow that defines whether it's phase 1 or phase 2 or phase 3. Okay. So the flow, hub and spoke is phase 1. Spoke to spoke is either phase 2 or phase 3. Now, what's the difference between phase 2 and phase 3 if both of them are spoke to spoke? The difference is phase 2 is accomplished, which is basically spoke to spoke traffic. I should say, I'll be more descriptive over here. In phase 2, the direct spoke to spoke data path is accomplished by tweaking the routing protocol. Got it? Now, phase 3. For EdgeRP, if you want the data path to go directly from what? Spoke to spoke, you can also use NHRP to accomplish this. Okay? In phase 3, direct spoke to spoke data path is accomplished by tweaking NHRP, not the routing protocol. So to recap, both. So you have phase 1. What is phase 1? And this is all for data. This is the routing hub. The data flow is like that. Phase 2 This is the routing hub. Multiple spokes. The data path. But this is accomplished by using the routing protocol. Now, phase 3, again, identical to what? In terms of the flow. What's the difference? Using an HRP to accomplish it. This is better. And I'll explain why as we go through it. But understand the 3 phases first. Everybody okay with the 3 phases? Good? More yeses. I know there's more than 3 people over here. There you go. All right, now understand this properly so you can see the difference. Let's say I'm sitting on R5 and I want to go to 10.2. I'm on R5, source, destination is 10.2. What does the routing table tell me about 10.2? Go look for 192.168.1.2. Okay, so where do I check? How do I reach 192.168.1.2? So my resolution over here is based on my routing protocol or routing table. I'm going to look for 192.168.1.2. Agreed? So I'm going to check my NHRP. And you will notice there's a mapping for what? This guy. So based on that, I'm going to create my packet. Like that. Good? Everybody okay with that? I need to have all the routes over here. And I will do the resolution based on that. And the resolution is going to be based on the routing table. From the routing table, I will check what? My mapping for the next stop created. Now, let's go back to phase 1. There is a need for specific routes then, absolutely. I would need to have specific routes for each route, basically knowing what the next stop is so I can go direct. Okay. Now, let's go back over here. I'm going to turn it back into phase 1. So all the routes now should be from where? What happened to 2? There you go. So I have all the routes. So everything now is pointing towards R1. Now with phase 3, I said I'm going to tweak NHRP to do the spoke to spoke. Right now, what does it show you? I'm going through where? R1. You guys pay attention over here. So if I'm on 5 and I want to go to 2, every time I'm going to be resolving for what? 1.1, and in my NHRP table, I'll see 192.168.1.1 pointing towards what? 10.1. So every packet goes through that. That's phase 1, hub and spoke, right? What I can do with this is on my NHS, I can build in intelligence into it in the sense that the packet, the data packet, when he send it, it's going through the NHS, but it's going back on the same interface towards R2. So the packet comes in through the tunnel, goes back on the tunnel, the data packet, correct? That basically tells NHS that 2 and 5 have direct reachability to them, because if the packet is coming on the tunnel, going back on the tunnel, that means technically they should be able to talk to each other directly. Okay, so what you can do is on the NHS, you can issue a command called NHRP redirect. What is NHRP redirect? Basically, when the packet came in, the first packet goes to NHS, it goes like this. 10.5 going towards 10.2. I'm using that as an example. Outside header, 50.5 to 10.1. 10.1 gets it, strips it off, sees 10.2, and it has a mapping for 10.2. So it'll flip this and now send the packet back onto 20.2. Hub and spoke. Everybody understood what I did over here. R5 sent it to R1. R1 received the packet, stripped the outer header off, saw the inside packet being 10.2.2.2, did the mapping again. 10.2.2.2 is reachable via 20.2 or 192.168.1.2. 192.168.1.2 is reachable via 20.2. Puts it in, sends it across. Understood? The 2 legs, 5 to 1, 1 to 2. I want to make sure everybody understood what I did over here. And the next packet, because of the next hop resolution, will also go through there. But when I put this command in, I NHRP redirect. It brings intelligence into it. It says, hey, listen, somebody wanted to go to the 10.2 network. In my routing table, 10.2 is reachable on R1. It's reachable via what? And I know 192.168.1.2 is reachable via 20.2. So this is in your routing table. This is in your NHRP table. It puts this information together and sends a redirect message to R5 saying, hey, listen, you know what? Why don't you create an entry for 10.2.2.0 if you want to reach that network? This is an NHRP message that's sending it. If you want to reach 10.2.2.0, it is reachable via 20.2. So the public address is 20.2. And he will actually create an entry. Up until now, I was just doing a NHRP entry for the 192.168 networks. Now I'm going to create an entry for 10.2.2.0, the actual destination. Up until now, I was not doing that. In my NHRP table, via the public address of this guy, the public address of the tunnel IP, which is in front of 10.2.2.0. So now you will have an entry like this where in the NHRP table, on R5. Because of this, although my routing table shows me what? Go through one, when the NHRP thing comes in, it overrides the routing entry. It says, hey, listen, go check the NHRP table, which will have this entry over there. What entry? 10220 is directly through there. So it will cause the packet to go direct between R5 and R2. But who caused it to go directly? It's the NHRP redirect that told it, hey, listen, don't send it to me, go direct. So on every router, actually you will have an entry for what? You will have an entry for the networks in where? Not only in the routing table, it will be overwritten by the NHRP table. So it's going to use the NHRP table to do the forwarding. And the NHRP table will take precedence over your routing table. So the routing table will point to 192.168.1.1, but the actual forwarding will be based on the NHRP table. But in the routing table, there will be a pointer saying, hey, listen, this has been overwritten. Notice this guy over here. You will see this against the route, saying this route has been overwritten. So what's the advantage of doing this? It is a more efficient way, faster way in terms of forwarding packets rather than doing a dual lookup, finding the next hop and the next hop going into NHRP cache, looking at it in the cache. Go directly to the cache. So end result is what? I am again going directly from where? Spoke to spoke. But what accomplished it? Not the routing protocol, but the NHRP messages. End result of phase 2 and phase 3 is the same. The end result of phase 2 and phase 3 is the same. The difference, phase 2 does it by tweaking the routing protocol. Phase 3 does it by tuning the NHRP cache. By tuning the NHRP cache is a more, how should I say, efficient way of doing it, a faster way of doing it. During the NHRP cache after 2 hours, it'll get reset. So it'll recreate the entry. So when the packet goes to the NHR, the hub, it'll send a redirect again. So maybe one packet will go through the hub and then the rest will go direct. Good. How do I do it? So to accomplish that, command on the routing hub, under the tunnel interface, IP NHRP redirect, telling it, hey, listen, if you see a packet coming in, going back on the same interface, figure out the mapping and send it to both the clients. Okay? But when I send the redirect, when the client receives it, it by default will ignore it. It doesn't do anything with it. Let me show you that. So I'll go to the hub. Under the tunnel interface, I'm going to say IP NHRP. Sorry. Redirect. So on the hub, I'm going to say IP NHRP redirect. I've done that. I've done my work on the hub. If I go to my spoke and I do a trace over here for 10.2.2.2, source is 10.555. Oh. This one has it. I don't know what happened. Down, bringing it up. Something happened, so I just bounced the interfaces. Okay. So I'm sitting on what? R5, I have 1, 2, 3, 4. I want to do a trace route 10.3. My next hop is pointing to what? This guy, show IP route or show IP NHRP. Okay. So I do a trace to 10.2.2.2, source of 10.555. Goes to 1, goes to 2. Try it again. 1 goes to 2. 1 goes to 2. Okay. Didn't I have the NHRP redirect command over here? So it is sending me redirects. But R5 is going as it's ignoring it. The reason it's ignoring it is in order for the spoke to take that redirection where it'll tell it, hey, listen, if you want to get to 10.2, this is the public address of 10.2. In order for the spoke to take it, it needs to have the ability to take that shortcut. So IP NHRP shortcut on the spokes. So all the spokes will have NHRP shortcut. Now, what's the implication of that? When I do the trace route now, it will send me that shortcut that will tell me in order to get to that network, and what do you call it, 10.2, this guy over here, use this as the public address. If I look at my NHRP cache now, you will notice that there's a new entry for 10.2. Up until now, I was only doing the entry for the next hop and then resolving the next hop. Now I actually have an entry for whom? 10.220, the actual destination with its public address. Now, if I check my routing table over here, notice what you see against the 10.2. Although it's showing you next hop is 192.168.1.1, there's also a % sign. Next hop has been overwritten. Okay? Everybody okay with that? Now, if I do the same trace route, although my next hop is showing 192.168.1.1, I'm going to use this and go direct. So although my routing table shows go through 1, my NHRP redirect, which causes me to create this resolution for the destination network via a public address. So now my packets are going direct from where? The spoke to the spoke. So end result of phase 2 or phase 3 is identical in the sense of what? I will go directly from spoke to spoke. But the way I accomplish this is a much better way of doing it, because now I'm using my cache to do the forwarding rather than my routing table. A much better, much faster way of doing it. Similarly, if I go to, let's say, 10.3, I want you guys to check my NHRP mapping right now. Show IP NHRP mapping. Let me do it right now. Notice I don't have any mapping for 10.3. Right? I have 10.2, I have 10.5, which is myself, 1 and 2, right? I don't have 10.5 or 10.3 over here. If I do a trace route right now to 10.3, I am going to send the packet based on my routing table to whom? Because I don't have any override done. 10.3 will go directly to what? 1. 1 will send me the redirect, in which I'll say, hey, 10.3, create an entry for it. It is reachable via 30.3. Take a look and you'll see that mapping also taking place, saying that if you want to get to 10.3, the next stop is this guy. So if I do show IP NHRP now, I will have an entry for 10.3 saying in order to reach 10.3, go directly from 30.3. I'll look at my routing table now, you will have that override. And now my trace route will go direct, spoke to spoke. So if you want to accomplish spoke to spoke, a better way of doing is by doing it using NHRP redirect. This did not exist initially, so you didn't have a choice but to do it based on what? The routing protocol tweak. If you wanted to do phase 2. Otherwise, hub and spoke is 2-1. Got it, Kenny? So on the routing hub, you do this and command on the spokes. You need to have it. Remember, before I had it, it would ignore it. But as soon as I have it, what does it do? Accepts it. Good? Yeah, one command on the hub and one command on each spoke. You guys understand the two, phase 2 versus phase 3. All right, now I'll show you another example, another advantage that you have over here. In phase 2, how did I accomplish spoke-to-spoke communication? How was it doing communication from, let's say, 10.3 to go to 10.2, go via this guy, using the routing protocol to modify the next stop of that route. So what routes did I have to have on R3 if I wanted to do communication directly from 3 to 2 and 3 to 4? What did I have to have on my routing table over here? I needed to have 10.2.2.0 in my routing table, and it had to say via 1.2, because I was doing it based on my routing table. Agreed? Understood? That meant any route that I have on any of these networks behind R2, R4, if I had other, let's call it other spokes over here, all the networks that they had, every one of them would be in my routing table over here, correct? Why? The way I accomplished direct spoke-to-spoke communication was by looking at my routing table. So I needed to have the actual route. One of the things that I can do over here is, if I want to, with phase 3, because I'm not using my routing table, I'm using the NHRP redirects. What I could do on this interface over here, I'm running EdgeRP, I could do a summary address. What do I mean by a summary address? What I can tell router 1 to do is, hey, listen, send a summary address to everyone. Don't send them the specific routes, just send a summary saying what? Anything that is 10.0.0.0/8, send it to me. So they would only have one route. But then when they wanted to go and do a trace to whom? 10.2, yes, the first packet, because the summary would be sent where? Where would it go? Here. And then it would go to 2, right? But at the same time, in phase 3, he would send a redirect. And that would allow me to go directly from 3 to 2. You understand that? So I could cut down on my routing table by summarizing on the hub and still accomplish spoke-to-spoke. But if I did it based on phase 2, because my actual direct spoke-to-spoke communication was done by looking at the routing table, I needed to have those routes in the routing table. So that's the other advantage that you have with doing it based on phase 3. Right now I'm on phase 3, so I could technically go over here and I can say IP summary address EdgeRP111, send the summary. So over here, I have 10.0 via this guy, correct? But if I do a trace to, let's say, 10.4.4.4, source 10.2.2.2, goes over there, no problems, first packet, then it goes direct. Why? Because now I would have an entry for 10.4 over here. What Sanat did was he just summarized the default, well, summarization or default route, yeah, either way. But this allows your routing table now on your spokes to be very small. Take a look. It just has, let's just do EdgeRP, it only has one EdgeRP route. But you still have spoke-to-spoke communication. If I wanted to do spoke-to-spoke with phase 2, I would need to have the individual routes. Understood? Absolutely. Yeah, but again, because it's a summary route, it doesn't. But you would have to check your NHRP to see that it is actually happening. The trace route would tell you that. Because the reason it's not showing that is because the summary route. Clear, everybody? So that is phase 3. Do you have a clear-cut understanding of phase 1, phase 2, and phase 3? Which one would you recommend? Big question. 1 or 3? The reason I'm saying that, 1 is what? Hub and spoke. This is spoke to spoke. 2 I wouldn't do 2 because 2 and 3 accomplish the same thing, but 3 is more efficient. There you go, Daniel. But I would pick between 1 and 3. Got it? Yeah, but absolutely. That's what I'm doing. Spoke to spoke with phase 3. Rather than using what? Spoke to spoke with phase 2. Because spoke to spoke with phase 3 gives you additional capabilities. It's a little better. Spoke to hub, meaning hub and spoke, you mean? Phase 3, generally the reason when you do the redirect is a phase 3, right? When you do a redirect, it's going to go directly from spoke to spoke. If you don't do the redirect, it is phase 1. Summarization is only possible in phase 3. You can also do it on phase 1. Because phase 1, if you do summarization, all the traffic will go to 1. 1 will then segregate the traffic to everybody else. You won't get spoke to spoke traffic, but phase 1 is anyways hub and spoke. Default is summarization if you really look at it. It's the biggest summary network that you have. You guys good with 1, 2, and 3? Okay. Now, the burning question. SPF, single point of failure. 2 doesn't support summarization. That is correct. If this goes down, shit out of luck. Everything is down because your routes are no longer there. Okay? So generally what you want to do in any type of environment, set up at least 2 hubs. So I'm going to make, let's say, LA and New York the hub. So they're going to act as what? My next hop servers as well as routing hubs for everyone. So in this case, my clients are going to be what? Rome, Sydney, and Dubai. Los Angeles and New York are my 2 hubs, 2 headquarters maybe. Okay? That's my objective. So what I'm going to do over here is I'm going to go to R2, no interface tunnel 1. So I don't have any config right now on R2 at this point. Show run. I should just have the interface IPs on the loopback and on the physical interface. Good. Right now, the way things are, Los Angeles is the hub, Rome, Sydney, and Dubai are what? My clients. So if I go to Rome, and I'm doing phase 3 over here. Show IP route, EIGRP. should be able to go to 10.4, should go direct. First one is the resolution, and then I should go direct. Should have 10.3 over here, or 10.4, somewhere right here. And I should be able to go to 5. Good so far, guys? So I have LA, I have Rome, LA as a hub, Rome, Sydney, and Dubai as spokes. Everybody on the same page so far? Okay, I want to make New York as my secondary next hop server. I'm assuming my routing hub is configured. My spokes are configured to point to the routing hub. Now I want to introduce redundancy into it. So basically what that means is I also want this to be my next hop server and routing hub. In case one goes down, the other one is there. How do I do it? Step 1, have a full working setup with a single hub, which we have accomplished already, right? Good so far? Once this is done, next, configure. I would do this. Copy and paste the tunnel configuration of the first hub into Notepad. Edit it for the second hub. So what I did was, what I would do over here is I would go to the first hub, show run interface tunnel 1, copy, paste it over here. What would I change over here? This guy. The rest I can keep the same. Good so far? Easy enough? I'm giving you a step-by-step cookbook of what you should do to do your redundancy. Clear so far? Configure a static neighbor relationship, NHRP relationship between the two hubs. What do I mean by that? On R1, IP NHRP map 192.168.1.2 is 20.2. IP NHRP map multicast, because I want to run what? Routing between R1 and R2. I'm not going to have it as a client, so I need to do a manual map. And R2, what do I do? Same thing for R1. Good? Because I haven't run EIGRP over here, I'm going to run it. Clear so far? Last step, configure the clients to also point to the second hub. So what they will do is they will register They're mappings to not only the first hub, but also to the second hub. So just in case one goes down, the other one is always there. So on the clients, which is R3, R4, and R5, all three of them. Interface tunnel 1, I already have the first one, I just need to add the second one. The 3 commands. And that's it. Your redundancy will be done. The reason is, now I'm going to have, I had R1 up and running. I copied the same configuration onto R2 and then did a static mapping between them. So they're going to be running EIGRP between them. So whatever he learns, he will tell him, and vice versa. Okay, Stephen, in terms of NHRP, I'm doing phase 3, correct? So in phase 3, when I'm going from 3 to 4, or 3 to 5, or 3 to 6, am I going through the hub? You're going to, in your routing table, yeah, you'll see 2 routes. It'll show you 2 routes in there, but the actual traffic will be direct. You get my point? We'll see that as well. It's active. So copy this first to 2. 2 right now did not have anything. So I copy the tunnel. On R, I'll do the R2 because I'm on R2 right now. I'll do the other part of R2. Done. And then the static mapping on R1, that would establish a EIGRP neighbor relationship between 1 and 2. Up with 1, up with 2. Done. Now all the other ones will not have a neighbor relationship unless I do what? Point them to the second hub. So if you go to 2 now, all are my neighbors. If I look at my EIGRP routes, I have all the routes. He's not sending me 1 because I done the summary over there. Okay. Now if I go over here to 5, what happens? Trace to 10.2.2.2. It's going direct. But if you check your routing table over here, it's got that summary route from both. So coming back to your question, Stephen, looks like it's going what? Load balancing, ECMP. But in reality, it's not. Why not? Because it's going directly from spoke to spoke. Now, if it was phase 1, then absolutely it'll do load balancing between the 2 spokes, 2 hubs. And that's something that you can see on the trace route, that it's going direct. It's not doing any load balancing. Not hard to do redundancy, is it? Especially if you follow these steps. It's very, very, very basic and works fabulously. That is correct. Very true. I don't want to do a spoke-to-spoke redundant, what do you call it? Neighbor relationships. It is inefficient to do that. So whether it's phase 1, phase 2, or phase 3, you want to cut down your neighbor relationships. You don't want to do a single hub. We talked about that. Have 2 hubs, but have all the spokes just do the neighbor relationship with the 2 hubs, and keep it at that. Good, everybody? Let's save this. Now, this one is knocked out. Dmvpn with IPsec. You guys realize all this work that we've done is, at the end of the day, it's still GRE. What does that mean? It's still clear text. It's multi-point, but it is GRE. Multi-point GRE, not encrypted. How did we encrypt a GRE tunnel? Do you guys remember? Using IPsec, right? In IPsec, what do I have? I have 2 phases. Same question that Stephen asked. I'm doing direct spoke-to-spoke communication. I'm not going through the hub. The hubs are there just to facilitate my, what do you call it? My resolutions. The actual data path is direct from spoke to spoke. So I'm not really going through any hub. We're all on the internet. So do you guys remember GRE with GRE over IPsec? Step 1 was what? Phase 1, crypto, ISACamp, policy 10, auth pre-share, hash MD5, group 2, encryption, triple des. Now the difference over here, haggle, crypto, ISACamp, key, Cisco 123, address. I have multiple addresses. Dmvpn is very scalable. And sometimes the addresses are dynamic. So generally what you do over here is you put address as 0000. Basically the Dmvpn key is Cisco 123. So all of them use the same key. A better way of doing it, which is not something that we're going to cover over here, is the certificate server. Better to do it using PKI. But if you're doing pre-shared key, use the same key for everyone. Done? Step 2. Do you guys remember? Crypto, IPsec, transform set, ESET, ESP triple des, as to ESP SHA and HMAC. Now, this is going to be GRE over IPsec. How many headers? ESP, GRE, and the internal. whatever the internal packet is, whether it's HTTP, ping, telnet, whatever internal packet is. 3, can I make it better? A little better. At least get rid of the duplication. Mode transport. So mode transport nowadays generally is used with MGRE because SVTI does not support multi-point, at least not right now. So this is where I would say mode transport. Step 3, because I don't have a crypto map, I need to have that IPsec profile. Crypto IPsec profile, whatever you want to call it, call the transform set over here. That was the last step. Apply the IPsec profile to the tunnel interface. Which basically says any traffic leaving the tunnel interface should be encrypted by using iProf. iProf calls key set, and it encrypts all the traffic using this, all traffic, and leaves the tunnel interface. That basically is done. Now take a look at this. Where do I need to do this? What device do I need to do this on? Which device? All the devices. And the thing is, it's the same configuration because everything is the same. So copy this and paste it to 1, 2, 3, 4, 5. The neighbor relationship would have gone down and come back up because of setting up of the IPsec. So it's up again now. Show crypto, ISECMP SA. I have the quick mode, idle, active, which is good. Crypto IPsec SA. It's encrypting already the EIGRP packets. So now you have, and it should be transport mode over here as well, somewhere. That is your encryption. That's all you got to do to encrypt it. It's basically the same concept that I talked about yesterday. The only difference is MGRE. Otherwise, it's still a GRE tunnel, so nothing changes. Same 4 steps that I used yesterday to encrypt my interface tunnel, I'm doing the same 4 steps today. What I try to do is rather than giving you 10, 15 commands together, I try to break it down into steps. For me, it's easier to remember steps. So if I remember there's 4 steps and in each step I have these particular commands, it becomes a lot simpler for me to keep it in your mind. Good? All right, now you guys becoming Dmvpn experts, huh? Go through it. This is what you need to know. Yeah, you need to practice. You definitely need to practice it. The last one, something that I would not do, but I'll show you. We've done this. Dmvpn with Ospf. Why would I do it? Because Ospf has issues with these tunnel interfaces. How many neighbors do I have over here on R1? Good, that's the only way to learn, Daniel. That's the best way to learn it. That's how I learn it. Any new technology that comes up, I keep on labbing it until and then do a lot of debug commands or Wireshark to see the actual characteristic of the protocol. That's how I learn. Ospf with tunneling is an issue. It doesn't work by default. The reason it doesn't work by default is Ospf works differently on different protocol, different interfaces. Ospf works differently on a point-to-point link. It works differently on an Ethernet link. It works differently on a frame relay link. And it works differently on a tunnel interface. On a tunnel interface, when it sees the encapsulation of the tunnel as what? Although it's multi-point GRE, it doesn't care about that. It is what? From the GRE family. It treats GRE as a point-to-point link. Okay? Now it's a point-to-point link, means I can only have one neighbor. But over here, how many neighbors am I going to have, even with Ospf? R1 is going to have how many neighbors? Going to have 4 neighbors, right? But this tunnel interface with Ospf will be treated as point-to-point, which only supports what? One neighbor. 2 routers, 1 neighbor, right? So it is, the first neighbor comes up, good. As soon as the hello packet comes from the other neighbor, it pulls this one down, brings the other one up. So it's going to keep on flapping. So how do I fix it? Change the default Ospf network type, which is point-to-point, to either broadcast or point-to multi-point. Which one? Which one is preferred? Well, each one has a specific characteristic that, depending on your need, you need to pick. What do I mean by that? Let's say I'm doing phase 1. Phase 1 means what? All the different spokes should point to what? To the hub, right? Agreed? So if you want to do that, you need to use point to multi-point, because point to multi-point is a network type that changes the next hop to self. If you use broadcast, it does not change the next hop. So the network type you pick is based on what phase you want to pick. With EIGRP, the default was what? Phase 1, because the next hop kept on changing to the hub. And if you wanted to do phase 2, you have to do that no IP next hop self, right? Here with Ospf, the default doesn't work because of that point-to-point type of issue that I have. So if you want to run Ospf over here, by default, Ospf treats a tunnel interface as GRE point-to-point. This only allows one neighbor. This will be an issue, as Dmvpn generally has more than one neighbor on the tunnel interface. So what's a fix? If you want to do phase one, phase one is hub and spoke. It requires the next hop to be changed on the hub. Okay? The Ospf network type point to multipoint has this characteristic. Okay, so what I need to do on each one of those devices, on all the devices, interface tunnel 1, IP Ospf, network, point to multipoint. As I said, it's an issue. You need to go through a lot of hassle to do that, but this is how you do it. And because, again, in phase 3, I want the hub to be the one that all the traffic goes through so that you can do a redirect. This is something that you would also do in your phase 3. So what I'll do over here, so that we don't need to do it, to say no router EIGRP 111, router Ospf 1, network. This is going to be for all of them. So this will get rid of EIGRP, run Ospf, and I'm going to do that tunnel network. Actually, let me do this first. In case of redundant NHS, if you're getting the routes from both sides, it's going to do equal cost load balancing if you're doing phase 1. Phase 2, phase 3 is direct spoke to spoke. So let's just do this. So I can show you at least between R1 and R2 the issue. R1, R2, R3. So what I'll do is on R1, I'm going to get rid of EIGRP. All my neighbors should go down, and I'm going to set up what? Ospf instead as the protocol. On 2, I'm going to do the same thing. Get rid of EIGRP and put Ospf as the protocol. Notice my neighbor relationship has come up between what? R1 and R2. No problems at this point, right? As soon as I go ahead and configure what? This guy. There you go. Now it's going to keep on flapping because you can only have one neighbor. And the reason for that, IP Ospf. Let's get rid of it. Otherwise, I won't be able to show you. Let's just do it on 1. Show IP Ospf interface tunnel 1. Notice the type. That's the issue. Yeah, I don't want to do that. Good. But to fix the issue, done. And the same thing I'll do on 2, 3, 4, 5. No problems now. If I go to 2, No, 2 is still the hub. Show IP route OSPF. Because I have 2 hubs, 4 and 5 are going through the 2 hubs. And as I said, it's going to do load balancing over here between one hub and the other. Equal cost multipath. Good so far, guys? So this is what? Phase 1. How about if I want to do phase 2? What I want you guys to see over here is 4 is coming to me via what? 2 or 1, which are my 2 hubs. It's not 4 is not coming from 4. Right? A hub is changing my next hop. Everybody notice that. Everybody notice that the hub is changing the next hop over here because of point to multi-point. Okay? Now phase 2, which was where the routing protocol gets tweaked so that the traffic is what? Direct. This one requires the next hop to remain unchanged. The broadcast OSPF network type broadcast has this characteristic. Okay, so if you want to do phase 2, you don't want to change the next hop to remain unchanged. You do broadcast, but keep one thing in mind. Broadcast has a DR, BDR election. Make sure the hubs are the only ones that are DR, BDR capable. Why? You don't want the spoke to become the DR because it's not communicating to the other spokes then. Not only that, the neighbor relationship will not form. Everybody needs to form a neighbor relationship with the DR, BDR. So they're not directly, technically they're going through the hub. They will not be able to reach it. So you need to make sure the hubs are what? DR, BDR capable. So on the hubs, what you do is, I've already done OSPF, so I'm just moving. On the hubs, it's just this, because I don't need to do anything special on the hubs. Just change it to what? Broadcast. But on the spokes, I want to make sure in L3 also do DR, BDR, L3 meaning phase 3. Whether it's on an L3 router, L3 switch, OSPF works the same way. OSPF is exactly the same whether it works on a switch or a router or a firewall. So it really doesn't matter. OSPF is OSPF. So on the spokes though, I need to make sure that they do not participate in the DR-BDR election. So I need to set the priority over here to 0. So they never become DR-BDRs. So I'll do this on the hub first, change the network type. My hubs were R1 and R2. And on the spokes, change the network type to broadcast, but also set the priority to 0 so they do not become the DRBDRs. 0 is a special priority that sets the no next hop. The broadcast characteristic is not to change the next hop. So when you set the OSPF network type broadcast, it automatically, the feature of broadcast is not to change the next hop. So the network type dictates whether the next hop changes or not in OSPF. Understood? So if I go over here now, let the neighbor relationship come up. It does take some time for OSPF neighbor relationship to come up, precisely 40 seconds. Could you do non-broadcast and point-to-point non-broadcast, but you want? But then you would need to statically input all the neighbors. So you're going away. Let's say you had 20, 20, 25 neighbors. You would need to put neighbor statements for each one. So you're getting away from that whole concept of scalability with Dmvpn. Technically you could, but you're losing on scalability over there. Got it, Kenny? So now the thing is, the neighbors are up. I can check my routes. Now you'll notice the routes are coming directly from the respective devices. Now the next hop is not changing. That's what I meant. When you put the OSPF network type as broadcast, the default behavior is not to change the next hop. So the way you accomplish phase 1 and phase 2 in OSPF is by picking the appropriate what? Network type. The network type will dictate whether you want to do phase 1 or phase 2. Phase 1, IP OSPF network type is point to multipoint. Phase 2, IP OSPF network type is broadcast. Clear? For phase 3, so for phase 3, just keep it as point to multipoint, because you do want everything pointing to the hub so that the redirect can take place. As you want the redirect to take place from the hub. And that is OSPF with Dmvpn. Everybody good? Or too much? Try to keep it as simple as possible. It is a, it's a pretty complicated topic. So that's why I try to keep it as simple as possible, going very slow at it. How do I set up for phase 1? You would work with your what do you call it? The parameters, the interface cost parameters, like for whatever routing protocol that you have, you work around with metrics, make one better than the other. So for example, let's say you want New York to be the better one. You go on to the interface of New York and change the IP OSPF cost. No, it's not, because the way a DR-BDR, I'm assuming that you're talking about the election process, right? The election process, the way it takes place, there's no preemption in that. So for example, let's say you had 3 routers over here. You have this router at 255, this router at 5, this router at 1. Let's say this router comes up first at 0000 time. This second router comes up at 0100. Third router comes up at 0200. Means 2 minutes later. So this one is up a minute before the other guy, and that one is up a minute before the other guy. When this comes up, it waits for 40 seconds, which is called the hold down time or hold time. Or wait time, not hold time, sorry. It's called the wait time in Ospf. It waits for 40 seconds to do an election. So if there's nobody else over there at that time and it does the election, it becomes the DR. Done? When this guy comes up 20 seconds later, because it did the election at 40, 20 seconds later, this comes up. It says, is there a DR out there? He says, yes, I'm the DR. It says, okay, I'm going to become the BDR. So although his priority is higher than him, because he came up in the first 40 seconds, he becomes the DR, he becomes the BDR. This guy comes up, he says, there's a DR, BDR already over there, he becomes a BDR other. So it's time. But if you had set it to 0, 0 is a special priority. 0 basically says, I'm not going to participate in a DR, BDR election. So even if the other routers come up first, they will not participate in any election. So they will not take up DR role until the hub router comes up. They won't be able to talk to each other, which is okay because unless the hub is up, the others cannot communicate anyways. Understood? That's exactly what I meant. Let's say the other router is the hub rebooted. The other one would become the BDR or DR. And there's no preemption in the DR BDR election. So there's an issue. So that's why you always, in a hub and spoke environment, the spoke should be set to a priority of 0. You might want to do an OSPF class one of these days. What will happen in hub redundancy design? Meaning, so you would put this, either one of them can be a DR, BDR. It's not that important, but they need to be a DR or a BDR. So make this a DR, this BDR. That really doesn't matter. That's not that big of a deal. As long as these guys don't become DR, BDRs, you're okay. The issue is over here, not on the hubs, because hub can communicate to everybody. Thank you, Marcin. And that too in 3 hours, huh? Good, guys. I'm glad. Now, spread the word. I'll tell you about my classes that I do. Not today, maybe on Friday. Thanks, guys. Tomorrow, what's the plan tomorrow? Let me check. Oh, yeah, we'll be doing this part tomorrow. Thanks, Tim. I don't sell videos, sorry. I do classes, but not the videos. You can sign up for the classes. All my classes, I record them. And I can send you a recording at the end of the class. I'll talk about that later on. maybe on Friday. Get the whole course done first, and we'll talk about it. All right, guys, you take care then. See you tomorrow. Don't miss tomorrow. Get VPN tomorrow. Take care, guys. Good night.